Greetings, we are ABIO Research, and this is the ABIO AI Journal Club. Today, we will discuss the manuscript entitled Preventing Premature Deaths Through Polygenic Risk Scores, authored by Melissa Chuang and collaborators, published in the journal Nature Communications on January 21, 2026. This presentation was created using the abstract's public information. Polygenic risk scores, or PRS, combine information from many genetic variants to estimate an individual's inherited risk for disease. Over the last decade, PRS have shown strong predictive power across many populations and conditions. However, a key question remains unanswered: how useful are these scores in real clinical practice? This study focuses on a very practical application of PRS, improving existing disease screening programs. One of the unique advantages of PRS is that they can be calculated from a single biological sample and remain stable throughout a person's life. This makes them especially attractive for long-term risk stratification. The authors used an integrated modeling framework to evaluate how PRS could be used to personalize screening strategies across 7 diseases that already have established screening programs. These include abdominal aortic aneurysm, breast cancer, colorectal cancer, coronary artery disease, hypertension, prostate cancer, and type 2 diabetes. Individuals were categorized based on their genetic risk. A high-risk group was defined as having a polygenic risk score corresponding to an odds ratio greater than 2, while a very high-risk group had an odds ratio greater than 3. The authors then estimated the age at which these individuals reached the same disease risk as the general population at the currently recommended screening age. The results were striking. On average, individuals at very high genetic risk reached the screening equivalent risk level 10.8 years earlier than the general population. High-risk individuals reached this level 8.9 years earlier. In contrast, individuals at reduced genetic risk reached this same level 16.8 years later. This shift in timing has important consequences. By targeting earlier screening to genetically high-risk individuals, the proportion of detected cases within these groups increased substantially. The enrichment of cases ranged from 1.7 to 3.0 times higher compared to population-based screening, depending on the disease. The authors then incorporated published data on mortality and clinical outcomes with and without screening-based interventions. This allowed them to estimate the real-world impact of PRS-guided screening strategies. Across all 7 diseases studied, appropriate interventions following PRS-guided screening were estimated to reduce premature deaths in high-risk individuals by 23.3%. This is a substantial effect, especially when aggregated across multiple common diseases. In summary, this study provides strong evidence that polygenic risk scores can move beyond risk prediction and into actionable public health tools. By tailoring the age of screening initiation based on genetic risk, existing screening programs could become more efficient, more targeted, and more life-saving. Overall, the findings suggest that integrating PRS into clinical workflows has the potential to significantly reduce premature mortality without requiring entirely new screening infrastructures. Discover how we can accelerate your research to achieve your scientific aims. We would like to thank you for joining us in this journal club. If you like the video, please let us know. For more information, contact us at sales@abio-research.com.